Somewhere in the cold, dark beyond Jupiter, a camera opened its eye one more time. What it captured was not an alien ship. It was not a flashing beacon or a message written in light. It was something far quieter and somehow far more unsettling. A single fuzzy dot hanging against a field of unmoving stars, fading with every passing week. And when astronomers pulled that image up on their screens in April of 2026, several of them sat in silence for a moment before saying anything at all. Because this was not just another picture of a comet. This was very likely the last clear look humanity would ever get of an object that came from another star, crossed our entire solar system in complete silence, and is now leaving forever. No goodbye, no warning. Just a smudge of light captured by the Hubble Space Telescope, drifting into the dark at more than 200,000 kilometers an hour and never coming back. To understand why that single faint image mattered so much, you have to rewind almost a year, back to the 1st of July, 2025. On that ordinary night, a survey telescope in Rio Hurtado, Chile, part of a NASA-funded early warning network called ATLAS, caught a tiny speck of light moving in a way that made no sense for anything native to our solar system. Most objects out there, asteroids, comets, even rogue chunks of rock, obey the same basic rule. They are gravitationally bound to the sun, looping around it again and again in closed, predictable ellipses. This object refused to follow that rule. Its path was hyperbolic, meaning it was moving too fast, on too straight a line to ever be captured by the sun's gravity. It was simply passing through. And when astronomers traced that trajectory backward, extending the line across the model of our solar system and beyond, it led somewhere no comet from our own neighborhood could have come from. It led out into interstellar space itself, toward the direction of Sagittarius, the same general direction as the crowded ancient core of our galaxy. This was only the third time in recorded history that anything like this had happened. The first was Oumuamua in 2017, a strange, elongated object that tumbled through our system and sparked years of debate about whether it might be artificial. The second was Comet Borisov in 2019, which behaved far more like an ordinary icy visitor. And now, here was a third confirmed interstellar traveler, officially designated 3A/Atlas, arriving at a staggering distance of about 670 million kilometers from the Sun, well within the orbit of Jupiter, moving at roughly 221,000 kilometers an hour, even before the Sun's gravity had begun pulling it in faster still. Scientists scrambled. Every major observatory that could possibly get a look at it was pointed in its direction within days. Hubble, Webb, even instruments never designed for this kind of object were repurposed on short notice because everyone understood the same brutal truth. Objects like this do not wait. They do not orbit. They pass through once, and then they are gone, forever, into the black. What made 3I/Atlas even stranger was its age. When the Hubble Space Telescope managed to estimate the size of its icy nucleus in August of 2025, the numbers alone were remarkable, somewhere between 440 meters and 5.6 kilometers across, a genuinely large body for an interstellar wanderer. But it was the calculations of its origin that truly stopped people in their tracks. Based on its trajectory and composition, some researchers estimated this object could be older than our entire solar system, potentially forming around a star system more than 7 billion years ago, meaning it may have been drifting through the emptiness between stars for literally billions of years before it ever crossed paths with us by pure cosmic chance at exactly this moment in human history. Think about that for a second. Every civilization that has ever existed on Earth, every war, every empire, every book ever written, all of it happened while this frozen relic was already tumbling silently through the void, completely indifferent to any of it. And it just happened to arrive during the narrow sliver of time when we finally had telescopes capable of noticing. As 2025 wore on, the object grew more active and more watched. In July and August, astronomers noticed something unusual in its coma, the cloud of gas and dust that forms around a comet's core as it warms near the sun. Normally, that glowing material trails behind an object, pointing away from the direction of travel, like a windsock in a breeze. But 3I/Atlas was doing the opposite. Its brightest plume of dust was pointing toward the sun, in the direction it was actually moving, not away from it. For a brief moment, some observers speculated this sunward glow might not be a tail at all, but something closer to an engine plume, a thought that spread rapidly online even as mainstream astronomers cautioned. It was almost certainly a natural jet of dust being blasted off the sunlit face of the nucleus as ice sublimated in the growing heat. Still, the image was hard to shake. A visitor from another star, glowing brightest on the side facing us, as if it were staring directly back. Then came October, the most dangerous phase of the entire encounter. On the 3rd of that month, 3I/Atlas swept past Mars at a distance of only about 29 million kilometers, close enough that multiple spacecraft orbiting the red planet turned their instruments toward it. hoping to catch a rare close-up glimpse of an interstellar body from a vantage point no human mission had ever had before. Then, on the 30th of October, it reached perihelion, its closest approach to the Sun, sweeping past at a distance just inside the orbit of Mars, at a blistering top speed of 68 kilometers every single second. At that moment, the object briefly vanished from view entirely, hidden directly behind the blinding glare of the Sun as seen from Earth, an alignment astronomers call solar conjunction. For roughly 10 days, nobody on this planet could see it. It was simply gone, swallowed by sunlight, doing whatever it was doing on the far side of our star with absolutely no one watching. That blackout window became, almost overnight, one of the most talked about gaps in recent astronomical history. Because in astronautics, there is a well-known principle called the Oberth effect. If you wanted to fire an engine to radically change your speed or direction using the least amount of fuel possible, the most efficient point to do it is exactly at your closest, fastest pass by a massive gravitational body, precisely because your velocity is at its peak. And 3I/Atlas reached that exact point, at its exact fastest moment, while completely hidden from every telescope on Earth. Was it coincidence? Almost certainly, according to the overwhelming majority of the scientific community, who point out that hyperbolic interstellar objects will inevitably pass near perihelion around the time they're closest to the Sun's glare no matter what, simply due to the geometry involved. But the coincidence was striking enough that even serious researchers couldn't resist asking the question out loud, if only to rule it out properly. What if something used that blackout window to do something? And what if we never find out? When the comet finally reemerged from behind the Sun at the end of October, the images that came back were extraordinary. The European Space Agency's Jupiter Icy Moons Explorer, JUICE, happened to be perfectly positioned to observe it from close range in the following weeks, catching the comet in what scientists described as an unusually active state, a bright halo surrounding the nucleus with a long tail stretching out behind it. NASA's Europa Clipper spacecraft, still years away from its actual destination, also caught the object in its instruments on the 6th of November, observing it for nearly 7 hours from about 164 million kilometers away, revealing twin tails and a distinctive glowing head. Around the same time, ESA's XMM Newton Observatory and the Japanese-led XRISM mission detected something that made headlines of its own, an enormous X-ray glow surrounding the comet's nucleus, stretching out roughly 400,000 kilometers, wider than the distance between the Earth and the Moon. By December, as 3I/Atlas made its final close pass by Earth on the 19th, at a safe distance of about 270 million kilometers, meaning there was never, at any point, any actual danger to our planet, the James Webb Space Telescope turned its extraordinarily sensitive instruments toward the object and delivered what may be the single most important piece of data in this entire story. Webb captured the first detailed mid-infrared chemical fingerprint ever obtained from an interstellar object, and what it found inside that ancient coma left scientists both fascinated and quietly unnerved. The chemistry was strange. Certain molecular ratios, particularly involving carbon dioxide and water, did not match the profile of typical comets born in our own solar system. It hinted at ices that may have formed in a colder, more distant environment than anything native to our neighborhood, chemical evidence that this thing really did come from somewhere else, carrying with it a frozen chemical memory of another star system entirely, one none of us will ever see directly. At the same time, a much louder, much more provocative voice had entered the conversation. Harvard astrophysicist Avi Loeb, already well known for arguing that Oumuamua might have been artificial, began publishing detailed analyses of 3I/Atlas almost weekly, eventually compiling a list of what he described as over 20 separate anomalies. He pointed to the object's retrograde orbit, tilted against the plane of the planets in a way he calculated had only a fraction of a percent chance of happening randomly. He pointed to its trajectory, bringing it unusually close to Mars and Jupiter while remaining hidden from Earth at its most critical moment. He pointed to a strange symmetric system of 3 jets discovered in processed Hubble images, spaced with an almost mechanical precision of 120 degrees apart. And he pointed to something almost poetic, the fact that the object's arrival direction lined up within 9 degrees of the origin point of the famous unexplained WOW signal detected decades earlier. None of this, Loeb was always careful to say, proved anything artificial. But taken together, he argued, it was worth watching closely, worth asking the uncomfortable questions, rather than assuming we already knew the answer. To really understand why Loeb's list carried so much weight with the public, it helps to look at a few of those anomalies more closely, one at a time, the way he laid them out himself. The retrograde tilt was the first thing that caught his attention. An orbital plane inclined at 175 degrees relative to the ecliptic, meaning the object was essentially moving backward relative to the planets, yet aligned with their orbital plane to within about 5 degrees. a coincidence he calculated at roughly a fifth of 1% likelihood if the arrival had been truly random. Then there was the timing itself, the way its closest approaches to Mars and to Jupiter both landed at distances that kept it tantalizingly close to each world without ever threatening a collision, almost as if it had been threaded through a needle. Then the jet system, revealed only after painstaking processing of dozens of Hubble images using a specialized filter that strips away the symmetric glow of a comet's coma to reveal finer structure underneath, showing not one, not two, but three narrow jets, spaced with almost geometric precision around the nucleus. And finally, that eerie alignment with the direction of the WOW signal, the still unexplained burst of radio energy detected from Earth back in 1977, a coincidence Loeb himself repeatedly stressed was not proof of anything, simply another data point too strange to ignore. The wider scientific community pushed back hard and consistently. Data gathered from multiple spacecraft, published in December of 2025, showed the object's unusual accelerations could be explained by something far less dramatic than propulsion, ordinary outgassing, the same process that causes any icy comet to get a small extra kick as sunlight boils material off its surface unevenly. ESA's own analysis in early 2026 described 3I/Atlas in strikingly plain language, calling it an extraordinarily normal interstellar comet, one still emitting the equivalent of 70 Olympic swimming pools worth of water vapor every single day as it baked in the fading sunlight, complete with the same sunlight-driven jets seen in comets that formed right here at home. Most researchers who study these objects for a living remain confident this is exactly what it appears to be. An old, well-behaved, thoroughly natural piece of ice and rock from another star, doing exactly what comets do when they get warm. It is worth remembering, they point out, that both of the previous interstellar visitors sparked very similar speculation in their own time. Oumuamua's strange elongated shape and unexplained acceleration fueled years of artificial origin theories before most of the field settled on natural explanations involving hydrogen outgassing. Comet Borisov, by contrast, behaved so ordinarily that almost nobody outside specialist circles remembers its name today. Every new interstellar object arrives as a blank page, and human curiosity, quite naturally, rushes to fill in the most dramatic possible story before the data has fully caught up. Skeptics of the anomaly framing argue that if you comb through enough measurements of any sufficiently unusual object, you will always find a handful of statistically improbable coincidences simply because so many different properties are being measured at once. That does not mean the coincidences are fake. It means that improbability alone, without a mechanism, is not the same thing as evidence. But confidence is not the same as certainty. And that gap is precisely where the fascination lives. Because by March of 2026, as 3I/Atlas made its final major planetary flyby, passing within about 54 million kilometers of Jupiter, close enough to nearly graze the giant planet's hill sphere, the gravitational boundary where Jupiter's own pull begins to dominate, it was already growing dimmer with every passing week. The bright, active visitor that had lit up observatories around the world for months was fading into a quiet, distant ember. And this is where the story turns from noisy debate to something far more haunting. Not a bang, but a slow, silent vanishing. By April of 2026, Hubble captured that image everyone keeps talking about. The object now sat roughly 1 billion kilometers from the Sun, nearly 7 times the distance separating Earth from our own star, already well beyond Jupiter's orbit, reduced once again to the same tiny, featureless, fuzzy dot it had been when it was first discovered 9 months earlier. The bright jets, the glowing coma, the twin tails, all of it had thinned and dimmed as the comet raced away from the warmth that had briefly brought it to life. What's strange, researchers noted, is that its brightness on the way out remains elevated compared to when it first arrived, a lingering afterglow of dust and gas still trailing behind it from its violent encounter with the sun, like the last embers of a fire that has already burned through most of its fuel. And now, as of the middle of 2026, 3I/Atlas continues its silent retreat, already tracked, drifting through the constellation Gemini, moving further from the sun and further from us with every single day. According to current projections, it will cross the orbit of Saturn, then Uranus, then Neptune, sometime around 2028, before finally slipping past the outer edge of our solar system's influence entirely, heading back out into true interstellar space, this time forever. There is no return trip. There is no second visit. Whatever this object is, wherever it truly came from, whatever secrets might still be locked inside its ancient frozen chemistry, it is leaving, and it is not coming back. Not in our lifetimes. Not in the lifetime of anyone who will ever be born on this planet. Which brings us back to that final image. Astronomers know, with near total certainty, that ground and space-based telescopes will only be able to track this fading dot for a limited window, longer before it simply becomes too faint, too distant, too small to resolve against the blackness of deep space. At some point, likely not far from now, the very last photograph of 3I/Atlas will be taken. Nobody will necessarily know at the time that it is the last one, not until months pass afterward, and no new image follows it. And then that will be it. The final frame of the third confirmed visitor from beyond our solar system, a visitor that may have been drifting silently through the galaxy for over 7 billion years, that passed within sight of Mars, brushed close enough to Jupiter to nearly touch its gravitational domain, carried chemistry from a star system none of us will ever identify, sparked one of the most serious scientific debates in a decade about whether we might not be entirely alone out there, and then simply continued on, indifferent, into the dark, exactly the way it came. Maybe it really is nothing more than an old comet, tumbled loose from some star system on the far side of the galaxy, doing precisely what ice and rock do when warmed by starlight. Nothing artificial, nothing intentional, just physics playing out exactly as it should. Or maybe, buried somewhere inside those 20-something unexplained anomalies, in that strange, symmetric jet system, and that trajectory so improbably aligned with our own planetary plane, there really is something we still do not fully understand. We may never know for certain, because unlike almost anything else humanity studies, this is not a mystery we get to keep investigating indefinitely. The subject of the investigation is leaving, right now, permanently. What makes this particular ending feel different from other astronomical farewells is the sheer scale of time involved on both ends. On one side, an object that may have spent 7 billion years or more adrift between stars, older than our own solar system by a margin so large it is difficult to hold in your head, silently crossing distances no human mission could traverse in 100 lifetimes, arriving at our doorstep for the first and only time. On the other side, a species that only finished building telescopes capable of noticing it a few short decades ago, and only had the technology to properly study it for the handful of months it happened to remain close enough to see. Somewhere in that mismatch of timescales lies the real reason this story captured so much attention around the world, far beyond the usual audience of dedicated astronomy followers. It is not really a story about aliens, or about jets, or about statistical improbabilities. It is a story about scale, about how briefly our entire recorded civilization intersected with something ancient beyond comprehension, for one narrow window that is now quietly closing. Astronomers are not simply letting it go without a fight. Plans remain in place to squeeze every remaining observation possible out of the fading months ahead, using the largest ground-based telescopes on Earth, alongside continued monitoring from spacecraft already positioned in the outer solar system. Every additional data point matters now because once 3I/Atlas drops below the detection threshold of even the most powerful instruments available, that data set closes permanently. There's no way to send a probe fast enough to catch up with something moving away from us at over 60 kilometers a second. There is no way to ask it to come back. Whatever has been recorded so far, the spectra, the trajectories, the jet measurements, the chemical fingerprints pulled from Webb's infrared instruments, is very likely all humanity will ever have on this particular visitor. A permanent archive, built from a handful of frantic, overlapping months in 2025 and 2026. And so the final image, whenever it actually arrives, whenever some observatory somewhere quietly captures the last usable frame before the object slips entirely into the noise of deep space, will carry a strange kind of weight completely disproportionate to how ordinary it will probably look. Not a dramatic close-up, not a clear view of a nucleus or a structure. Almost certainly just another faint, blurry point of light, barely distinguishable from the stars around it. The same kind of image that started this entire 9-month-long fascination back in the summer of 2025. A quiet bookend to a story that opened with a spark of discovery and closes with a fade into silence. Somewhere out past Neptune's orbit sometime around 2028, without ceremony, without confirmation from anyone still watching, 3I/Atlas will cross the final threshold of our solar system's gravitational influence and continue on, unchanged, uninterested, into the endless dark between the stars, carrying whatever secrets it holds, natural or otherwise, to a destination none of us will ever know, and none of us will ever be able to follow.